Hey coders, what's up? So today we are going to solve day 12 problem in the July Leetcode challenge. So this problem is titled as reverse bit. Let's see what we'll have to do in this. So we are given a 32-bit unsigned integer and we need to reverse its bit. So let's see this example. So in the first example, as you can see, the digits, the bits have been reversed. So from 00111 and now 0011s came at the 0th index or the starting position from the ending position, and similarly the first few zeros has gone to the end of this. Similarly, like as you can see in this case, we have 100 and 10 has come at the start of the string, and rest of the numbers have gone to the end. So as you can see, uh, so so I think the most basic solution for this will be to convert the number uh, into a bit representation, and then reverse the bit representation, and then uh, it convert it back to a number. So what I mean is that, so let's say you have 13 as your unsigned number, and then the bit representation of 13 would be 1 1 0 1. So I think this one is for 1, and this is 0, and then this is 4, and then this will be 8 plus 4 plus 1. So this is my bit representation of 13. Now if you reverse it, you will get 1 0 1 1. So this is a string essentially, and if you reverse a string in a Python format, you can do it like string and something like this, and it will give you a reverse of a given string, and you will get this. So let's call this string as s. So if you do int of s with a base 2, then you will get the actual integer. So this will be your output, right? So you can iterate. So this is a first approach. Let's just code it and see if this works. So the to get the bit representation of in the form of string, I'm just converting into this format. So I think this will give me bits, and then I will just return by reversing the bits. I will simply have it like in 2 and like this. Let's see if this works. This should work for the most part. As you can see, this worked. Let's try to submit it. So this got accepted, but as you can see, the time complexity is not that great. So let's just try to modify it. Would be to basically consider, so let's say in case of 13, we have a binary string that will be represented in the form of this, right? The idea is quite simple. If we move the binary representation from this side to this side, and we keep populating our output, so let's say our starting output is 0, and if we keep shifting the bits of output from left to right, then we know that whenever we shift a binary representation from left to right, it add a 0 here. So it keep adding 0, and because we are already provided the integer is 32-bit, so we can have we are definitely going to have 32 length string of this, so we can have a for loop for 32 iterations, and we keep doing this, like keep shifting the output to the right and keep shifting the input to the left, and we also need to make sure that we put whatever we get from multiplication, or like we need to do some operation to get this bit at each of the point. So for example, if I have one and so let's out will give me 0 if my out is 0. So 1 and 1 is 1, 1 and 0 is 0, 0 and 0 is 0, right? And see, so and 1 or 1 is 1, 1 or 0 is 1, 1 or I would say 0 or 0 is 0. So basically to get this bit at any position, we need to do like so let's call this as num. So if I call like num and 1, this will only give me 1 if my current digit is 1, right? In all other cases this will give me a 0. So if I do it for this position, so 0 and 1 will give me 0. So that way I can get the digit, and if I do it with all of current digit which is out, so if any one of these is 1, it will give me 1. So this simply we return the value of this, whatever is the value of this. So we can conclude that out will be equal to out or num and 1. So num and 1 will give you the correct digit whatever is at that place, and out will be 0 initially. So if this is 0, you will get out as 0. If this is 1, you will get out as 1. So in that way we can formulate our solution or algorithm something like this. So for I 1 to 32, this is inclusive. So I'm now starting from 0 to 31. So from 1 to 32, what we are doing is we are shifting the input, or we have our output at 0 initially, and what we are doing is we are shifting output to the left, right, by 1 bit, and then we are doing output is equal to output and num and 1, and then we are shifting input to the right side. So if we shift input to the right side, this will keep going to this direction, and this will keep going to that direction. So in that way we can get our output, like the reverse string will be output, so we can simply return output at the end of our loop. So this will become return output. So let's just write code for this and see it working. So I'm commenting this old solution and let's just have out equal to 0 initially, and now we are using a for loop till 32, and then for each of, so we are shifting output to the left side of this, and we are, so our output will become output all. So this is a bit or operation, I would say, and then whatever is our input, so basically and one, and then we will shift n to the right side by 1, and we can simply it out here. Let's see if this works. This worked for this. Let's try to submit it. Yeah, this code accepted. I don't know why it's showing the worst time complexity, but the thing is, if you are not allowed to use any of the library functions or any of the, the source or these kind of operations, then you will have to code it like this in a real interview. Since so this loop is running 32 times, I think the time complexity will be kind of a constant because we know how many times we'll have to do this, so this is kind of fixed. So yeah, I hope you enjoyed this video. Please don't forget to like the video and subscribe to the channel, and see you in the next video.